All right, guys, we are simplifying rational expressions and solving rational equations. And this is the test review for that test. The first couple problems just want us to simplify the expression. So they are only asking you to cross out common factors and rewrite the expression in simplified form. And so what we're looking for is exactly the same thing on the top and the bottom. And remember that this x is married to the 8, this x is married to the 5, this is married to the 1, and this is married to the 8. So while you see a whole bunch of x's here, only the pairs can be crossed out. So if I'm going to cross out x minus 8, I have to have another x minus 8 in the bottom of the fraction. And we do. So we're going to cross out both the x minus 8s. And while I have an x here and an x here, this x is with 5 and this x is with -1, and they cannot be separated. Cannot be separated. So this, in simplified form, this expression is just x plus 5 over x minus 1. And you're done. For this expression, we have to do the factoring. So I am going to factor x squared minus 64. That factors to x plus 8 and x minus 8. And then I'm going to factor the x squared plus 10x plus 16. We need things that multiply to 16 and add to 10. That's x plus 8 and x plus 2. And again, I'm looking for exactly the same set of values in the top and the bottom. So x plus 8, those cross out. And I'm left with x minus 8 over x plus 2. And that's our answer, right? We're done. Don't cross anything else out. This x is married to the 8, this x is married to the 2. You cannot separate those numbers from their variables, so x from that number. All right, moving on, we're multiplying and dividing. Remember that to multiply, you factor completely, you smoosh, and then you cross out common factors. So there's nothing to factor here, so I'm going to smoosh. This is 7 times x plus 3 over 49 times x plus 3. And so this is the smoosh step, and then I look for common factors, things that are the same. X plus 3 and x plus 3. I end up with 7 over 49. And you want to make sure that you can't simplify that. So do 7 and 49 have a number in common? They do. It's 7, so this is 1 over 7 is what it simplifies to. All right, this expression right here, we've got a factor. So x squared plus 5x minus 36, things that multiply to negative 36 but add to 5. That's x minus 4 and x plus 9. And then x plus 1 on the bottom. Times 5x plus 5, that's not a traditional factoring problem like this, but I'm looking for something that 5x and 5 have in common. They have a 5 in common, so it's x plus 1. And then x squared minus 16, that factors to x plus 4 and x minus 4. And now I smoosh. So this is, I'm going to write the 5 at the front just because that's correct. 5, x minus 4, x plus 9, x plus 1 over x plus 1, x plus 4, and x minus 4. And so now that I've smooshed, I'm going to cross out common factors. This is x minus 4 and x plus 4. And rewrite what's left. So in this case, guys, that is 5 times x plus 9 over x plus 4. And walk away from it there. Walk away from it there. This is your answer. You are done. All right, don't distribute the 5. Just don't do it. You don't need to. All right, remember that when we divide, what we do is we flip the second fraction and multiply. So this is x squared minus 2x minus 8 over x squared minus 4 times x plus 4 over x squared minus 6x plus 8. And so when we factor, so x squared minus 2x minus 8, it factors to x minus 4 and x plus 2. x squared minus 4 factors to x plus 2 and x minus 2. And then x plus 4 just stays, right? You don't need to factor there. X squared minus 6x plus 8 factors to x minus 4 and x minus 2. All right, and now we're going to smish. So we're going to just throw it all together in one fraction. So this is x minus 4, x plus 2, x plus 4 over x plus 2, x minus 2, x minus 4, and x minus 2. We're looking for things that are common to the top and bottom. I have an x minus 4 there and there. I have an x plus 2 there and there. I have two x minus 2's, but they're both in the bottom of the fraction, so I can't cancel them out because it's got to be in the top and the bottom to cancel out. And so we're left with x plus 4 over x minus 2 times x minus 2. You can leave it like that. That is totally fine. Full credit for that answer. But if you would rather write it as x plus 4 over x minus 2 squared, that's also acceptable. Either of these answers are totally fine. They mean exactly the same thing. All right. We're moving on to addition and subtraction. And when we do addition and subtraction, remember that you've got to find a common denominator. So these next problems have you finding the least common denominator. So we do that by identifying what the denominators have that is the same and then what they have that is different, because all of those things have to go into our least common denominator. So I've got 2x and 7x. Those denominators both have an x, so that's going to be part of my common denominator. And then 2 and 7 don't have anything in common. I can't easily make 2 into 7, and I can't easily make 7 into 2. So both of those things go into my LCD. And then I just rewrite it simplified. So 2 times 7 is 14 and x. All right, for this one, I'll look at my two denominators. They don't have anything in common. They both have x's. But remember, this x is tied to 1 and this x is tied to -5. We cannot separate them. They are stuck together. So that's two separate pieces, an x plus 1 and an x minus 5. So my LCD here is x plus 1 and x minus 5. All right. This one right here, we need to factor. So x squared minus 64 factors to x plus 8 and x minus 8. And you want to factor so you can really see what you've got. So my LCD here is the thing that they have in common. They both have an x plus 8. So that's part of my LCD. And then anything else that's in a denominator. So look at it. I have an x minus 8 right here. So that's part of my common denominator as well. Anything that exists in either of your denominators has to go in the LCD. And we can save some work and some time if we notice common things, because then we don't multiply by as many factors when we are finding the common denominator. All right, guys. We are going to, we're going to add and subtract now. And remember, to add and subtract, you've got to have a common denominator. And so this fraction right here, our common denominator is 5x, and they both have a 5x, so we're good. We're good. We don't have to change anything, and what you do is you just add the tops together. So this becomes x plus 7 plus 3x minus 4. Over 5x, which is 4x plus 3 over 5x. And that's your answer. Just put together common factors. And you know, if you can simplify, you should, but we can't simplify there, so we're good. All right. For number 10, 4y and 5y are not the same, so we do have to identify an LCD. And you should always identify it there so that I can see that you knew you were supposed to find one, right? So it's what they have in common, which is y, and then anything that either of them has. Well, 4 and 5 are not common, right? I can't make 4 into 5 and I can't make 5 into 4. So I'm going to put them both in my LCD so I get 20y. That's my least common denominator. So I'm going to make these both into 20y. I do that with my first piece by multiplying by 5 over 5. And then my second fraction, the y plus 1 over 5y, to make that 5y into 20y, I multiply by 4 over 4. And this becomes 25 over 20y minus 4 times y plus 1 over 20y. Resist the urge to simplify at this step. Remember that if you simplify at this step, you just end up right back here. So now we need to add, or rather subtract, these fractions. So this is 25 minus 4 times y plus 1 over 20y. And then go ahead and distribute that 4. So 25 minus 4y minus 4 over 20y. This is 21 minus 4y over 20y. And I know that this looks like I should be able to cancel out those y's, and this 21 and this 20, they look awfully appealing. But guys, the 21 and the 4y, they are together forever, cannot be separated. We can't cancel out any y's here, and so this is your answer. We just leave it like this and walk away. All right, looking at number 11. Again, these two do not have a common denominator, so I have to come up with that. They don't have anything in common at all. So my LCD for them is just both of those pieces together. It's x minus 4 and x plus 3. That's my common denominator. And so to get this denominator with this fraction, I multiply the top and the bottom by x plus 3. So x plus 3 over x plus 3. And then plus 7 over x plus 3 times x minus 4 over x minus 4, like that. And so what this does is it gets the common denominator for both of my fractions. So this is 5 times x plus 3 over x plus 3, x minus 4, plus 7 times x minus 4 over x plus 3 times x minus 4. And then we're going to go ahead and distribute. I'm sorry, let's put those together first. Let's not distribute yet. So 5 times x plus 3 plus 7 times x minus 4 all over our common denominator. Okay. Resist the urge to simplify. You can't cancel any of this stuff out. This x plus 3 is here and here, but it's not there, and the x minus 4 is here and here, but it's not there. You can't cancel at this point. Let's go ahead and multiply out. So distribute the 5 and distribute the 7. This is 5x plus 15 plus 7x minus 28 over x plus 3 times x minus 4. That is 12x minus 13 over x plus 3 and x minus 4. And we are done. Walk away. There's nothing you can simplify there. All right, number 12 works in exactly the same way. My LCD here is x plus 3 and x minus 1. They didn't have anything in common, so we just put them together, the two denominators. To fix this fraction, so it's got my LCD, I'm going to multiply by x minus 1, and I'm going to multiply this fraction by x plus 3. So x minus 1 over x minus 1 times 7 over x plus 3 minus 3 over x minus 1 times the x plus 3's. And when we do that, we get 7 times x minus 1 over x minus 1 and x plus 3 minus 3 times x plus 3 over x minus 1 times x plus 3. Let's go ahead and put those two fractions together. So this is 7x minus 1 minus 3x plus 3 over x minus 1 and x plus 3, like that. And we need to go ahead and distribute the 7 and distribute the 3. And remember, the 3 is negative, guys. So this is 7x minus 7 minus 3x minus 9. Make sure that negative makes it to both those terms. Over x minus 1 and x plus 3. So 7x minus 3x is 4x. And negative 7 minus 9 is negative 16 over x minus 1 and x plus 3. And you may have noticed that 4x and 16 have something in common, and you are correct. They have a 4 in common. So if I factor out that 4, I get x minus 4 on the top of this fraction. And that certainly looks prettier and more simplified, but I will take either answer for full credit. Either one gets you full credit. If you want to leave it as the 4x minus 16, you're totally fine to do so. All right, guys, number 13 is just a little different. It's actually easier than the other ones, though. For this one, we need to factor. So this x squared plus 7x plus 6, it factors to x plus 6 and x plus 1. It's another one of those one difference between this number and this number, right? So that's what it factors to. And so the denominator for this 2x is x plus 6 times x plus 1. Well, to find our LCD, we say, do they have anything in common? In this case, they do. They both have an x plus 6, so that's what we write first. And then, in addition to the x plus 6, this fraction has an x plus 1. So that also has to be part of my denominator, because I can't take that out of a denominator, right? Like there's no way to get rid of that. So I've got to add it to the other one. All right, so this fraction stays the same. It already has the common denominator, so we leave it. This is x plus 6 over x plus 1 plus 7 over x plus 6, and then I'm going to multiply this by x plus 1 over x plus 1. And so that's 2x over x plus 6 times x plus 1 plus 7 times x plus 1 over x plus 6 times x plus 1. All right, and you can go ahead and put those two together. This is 2x plus 7 times x plus 1 over x plus 6 times x plus 1. Like that. Distribute the 7 and then combine like terms like we did in the problems above. So this is 2x plus 7x plus 2 over x plus 6 times x plus 1, which is 9x plus 2 over x plus 6 times x plus 1, like that. And that's your answer. Leave it alone, walk away. All right, guys, we're moving on to solving equations. Moving on to solving equations. And the first 3 equations that we're going to solve are cross-multiply equations, which we love because they're super fun and also super easy. But before we start solving equations, we need to talk about excluded values. Remember that you cannot have 0 in the denominator of a fraction. So before we mess with these at all, what we do is we look at the denominators and we say, okay, are there any numbers that are going to make either of those denominators 0? And in this case, the answer is yes. -3 would make this denominator 0, and +3 would make this denominator 0. For my excluded values are 3 and -3, right? X cannot equal either of those numbers. So now I'm just going to go ahead and solve this equation. We do that using cross multiplication. So I get 4 times x minus 3 is equal to 5 times x plus 3. So 4x minus 12 is equal to 5x plus 15. That wasn't distributing, right, guys? Solve for x. So I'm going to move the 4x over. Negative 12 is equal to x plus 15. Subtract 15. I get x is equal to negative 27. And I look back at my excluded values. I say, was negative 27 one of my excluded values? No, it wasn't. And so we're good. Negative 27 is a valid answer. It's not extraneous. We don't need to worry about it. We just box it and walk away. All right, looking at number 15, we want to again talk about excluded values. And so anything that's going to make our denominator 0. But if you look at this, my denominators are 2 and 4. There are no variables. And that means that I don't need to worry about those becoming 0 because 2 and 4 cannot be made 0 if there aren't any variables there. So I don't have any excluded values. I'm going to go ahead and cross multiply. So I've got 4 times 3x plus 1 is equal to 2 times 3x minus 7. And then distribute the 4 and the 2. So 12x plus 4 is equal to 6x minus 14. And then solve for x. Subtract 6x. 6x plus 4 is equal to negative 14. Subtract the 4. 6x is equal to negative 18. Divide by 6. X is negative 3. And since I didn't have any excluded values, we're good. All right, last cross multiplication problem. First, we address excluded values. This fraction does not have an issue. 5 will always be 5, but here, x cannot be negative 3. X cannot be negative 3. All right, now we're going to cross multiply. So I've got x times x plus 3 is equal to 5 times 8. So x squared plus 3x is equal to 40. This is a factoring problem, we know, because there's an x squared and a 3x. So we're going to have to move that 40 over. So x squared plus 3x minus 40 is equal to 0. And then I'm going to factor things that multiply to 40 and add to 3. It's a negative 40, so one's positive, one's negative. That's x plus 8 and x minus 5. And then set them both equal to 0. X plus 8 is 0, and x minus 5 is 0. X equals negative 8, and x equals 5. And then I check, and I say, okay, were either of those numbers my excluded value? And the answer is no. So they both work. They're both solutions to this problem. We're good. See, wasn't that fun, guys? It was fun. All right, y'all. For number 17, 17, 18, 19, and 20, we are finding a common denominator. So we're going to multiply through by our common denominator to get rid of all the denominators, get rid of all the fractions. But guys, for number 17, they are all sitting on top of a 5. All those denominators are the same. We don't need to do anything. We just say, hey, if all the denominators are exactly the same, that means the stuff in the top is equal to. So this is 3 plus 2x plus 8 is equal to 13. And we could only do that because of the 5s, because they are all exactly the same. But they are, so we're good. So this is 2x plus 11 is equal to 13. Subtract 11. 2x is equal to 2. X is equal to 1. And I forgot to talk about excluded values on this problem because there aren't any. Because 5 will always be 5. We don't have any variables in our denominator, so we're good. X equals 1 is our answer. All right, for number 14, let's talk about excluded values. What will make this denominator 0 if x equaled 0? So x cannot equal 0. 5 is always going to be 5, so we're good. And now let's talk about our LCD. So that is what what they have in common and then anything else there is in a denominator. In this case, there are two fractions with an x. So that goes here. And then in addition to the x, there's a 5. So that goes there. So that's 5x. So 5x over 1 is, I'm going to multiply through the entire equation by that denominator. 3 over x plus 8 over 5 is equal to negative 13 over x. And guys, don't do the multiplication, just leave them next to each other so we can cross things out. So this is 3 times 5x over x plus 8 times 5x over 5 is equal to negative 13 times 5x over x. So see that I have not actually done any of that multiplication, I've just left it. And that's so that I can go through and cross things out. So these x's are gone, and that's just 3 times 5. The 5's are gone, so that's just an 8x. And then the x's are gone here as well, so that's negative 13 times 5. All right. And so this is 15 plus 8x is equal to negative 65. And then solve the equation like we would, right? So subtract 15. I get 8x is equal to 80. Divide by 8. And I get x is equal to 10. That's my answer. All right, and we come back up here, guys, and it's right up at the top of the screen, I'm sorry. But right here, our excluded value was 0. This is not 0, so we're good. That's our answer. We're good to go. All right, guys, only 2 more. And these are fun. These are fun. All right, y'all. So here, first, it's an equation, so I need to talk about excluded values. So what would make either of these denominators 0? And the answer is 2. So x cannot equal positive 2. And then our LCD. What's in the bottom of these fractions? There's an x minus 2. This 7 has a 1 underneath, so we could say times 1, but you know, at the end of the day, that's just x minus 2 still. So that's our LCD. And so we're going to multiply through by x minus 2. I'm going to multiply everything by x minus 2. So 10 over x minus 2 plus 7 over 1 is equal to 5x over x minus 2, like that. So this is 10 x minus 2 over x minus 2 plus 7 times x minus 2 over 1 is equal to 5x times x minus 2 over x minus 2. And then cross out common factors. So these x minus 2's are gone, and these are as well. And that leaves you 10 plus 7 times x minus 2 is equal to 5x. And just solve that equation, guys. Just distribute the 7. 10 plus 7x minus 14 is equal to 5x. You move the 5x. So, and the 10 and the 14, this is 2x minus 4 is equal to 0, right? Because I moved that 5x. And then I'll move the 4 back over. Add 4. 2x is equal to 4, which makes x equal to 2. And what we want to do is we want to throw a box around that number and just walk away, because that's our answer. We have to come back up to the top of this problem, and we have to look at our excluded values. And our excluded values for this problem, right there, x cannot equal 2. And so what we do is we mark through this, and we say nope. We say extraneous. And remember, that's the word E-X-T-R-A-N-E-O-U-S. All right, so mark through it and say extraneous. Don't erase anything. Leave all your work there so that I know that you know how you got that answer, but I also need to know that you know that answer is wrong. All right, guys, last one. Oh, and this one's fun. This one's fun. Okay, factor everything. So this factors to x plus 4 and x minus 3. This one factors to x minus 5 and x plus 4. And this one factors to x minus 5 and x minus 3. All right, guys, and then let's find our LCD. All right, I've got an x minus 4 or an x plus 4. That takes care of this guy and this guy. I've got an x minus 3, which takes care of that guy and that guy. And then I've got an x minus 5, which takes care of that guy and that guy. And what we have to do is we'll have to modify each of these fractions so that they have this whole denominator here. Now, we only have to multiply each of these fractions by one of these values, right? Only by one. So don't freak out. Don't freak out. All right, I'm going to multiply the entire thing by my common denominator. Let's see if I can make this a challenge, see if I have enough space. So this is 6 over x plus 4 and x minus 3 plus 8 over x minus 5 and x plus 4 is equal to 4 over x minus 5 and x minus 3. There we go. All right, and then this piece right here is going to go into each of these numerators. So 6, x plus 4, x minus 3, x minus 5 over x plus 4 and x minus 3 plus 8, x plus 4, x minus 3, x minus 5 over x minus 5 and x plus 4 is equal to 4. Ooh, we've run out of space, guys. X plus 4, x minus 3, and we'll just put it right here, x minus 5 over x minus 5 and x minus 3. All right, so now is the fun part where you get to cross things out. So I've got an x plus 4 and an x plus 4 and an x minus 3 and an x minus 3. And that leaves me right here with 6 times x minus 5. How simple is that? Isn't that good times? And then I've got x plus 4 and x plus 4 and x minus 5 and x minus 5, and they go away, and so I get plus 8 times x minus 3. How exciting is that? And then x minus 5 and x minus 5, x minus 3, x minus 3. That's equal to 4 times x plus 4. And so look, this crazy pants complicated equation comes down to just this right here. This is 6x minus 30 plus 8x minus 24 is equal to 4x plus 16. So that's 14x minus 54 is equal to 4x plus 16. Add 54. 14x is equal to 4x plus 70. Subtract the 4x. And you get 10x is equal to 70. Divide by 10. X is equal to 7. Now, you may have caught me and noticed that I did not talk about excluded values. I did not talk about excluded values, and you are right. I did not talk about excluded values for this problem. That is bad. That is bad. So I'm going to look back up at my LCD right here. Here, I'll zoom out a little bit, although it might make it harder to see. Here's my LCD right here. And I'm going to look back up at this, and I'm going to talk about my excluded values based on that LCD. What would make x plus 4 0 and thus the denominator 0? Negative 4. So x cannot equal negative 4. What would make x minus 3 0 and thus the denominator 0? that would be 3. So x cannot equal 3. And what would make x minus 5 0? And thus the whole denominator 0? That would be 5. And so our excluded values here were -4, 3, and 5. And since 7 is not one of those numbers, we're good. That is my solution to this problem. All right, kidlets, I hope that helped. Study for this test tomorrow. I hope that you guys all do well.